how we roll, man. Some rock, some win, some 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 win.
So, hello everybody, welcome to Zig Showtime episode 33. And well, it seems like we've depleted, like we've consumed all the individual events that you can represent with 5 bits. So now we are at our 6th bit. So I don't know, let's try to make good use of it and enjoy it as well, I guess. So since people have been complaining that I've been spending way too much time with introductions and like in intros, I guess we're gonna move very quickly to the talk. Actually, it's just because I don't have anything else to say this time. So I will take my sweet time next time if I have to, if I want to. And yeah, let's move in to the talk right away. So Buzz is a lightweight scripting language written in Zig. We've seen also other scripting languages written in Zig. I remember long-time users of Zig can remember Lola, for example, which was also talked about on Zig Showtime. But while it's easy to think, oh, it's yet another scripting language, what I think it's a more interesting perspective is to take the time to really appreciate the tiny differences. Benoit has been working in like a more corporate environment, and I think he has found like a creative outlet in designing this programming language. And you will find that compared to, for example, Lola that I mentioned because it was a previous talk on the show, you will see that there are like plenty of interesting differences. And those differences are not necessarily just like a matter of taste and like creativity. Some are maybe, but also there might be some critical differences that may make the difference between one being the exact solution to a problem that you might have. So please pay attention and let's welcome, chat, please, let's help me welcome Benoit Giannangeli.
Thanks, Loris, for having me. I want to talk today about this project I've been working on. So I've been working on this for about 2 years. I started without really having any plan. I was just having fun, and then I got a little carried away. So first, I want to tell you a bit about myself. I'm working at an online bank in France, which it's called Boursorama. It's the biggest online bank in France with over 5 million customers. So I do a lot of stuff for them. Mainly my job is about making technical choices, laying down the ground for developers to come in and work. So that's about it for my professional life. And on the side, I do a lot of stuff. So in 2017, 2018, I created Fengari, which is the Lua VM written in JavaScript so that it can run in the browser. I did this with Darly Matter that you might know with a contributor to Zig. And it was quite fun. So you will see that I have an history with Lua. Another thing I did a lot with Lua is making games, making unfinished games, one of which is Settlers of the Deep, and you can test out. It's available right now, even though it's not really finished. And working on that game, I found that Lua was a little too slow to do what I wanted to do with the game. So I switched to Zig, and that was the first time I did anything with Zig. And I rewrote the entire game with it. Other things I do is drawing, so you can go on Instagram and see what I do if you are interested. So let's talk about Buzz. So Buzz is a small language. It's garbage collected. It's just-in-time compiled, and it's statically typed. So it's not granular typing. You can't opt out of the type system. And I think it's a strong selling point for the language. At my work, I've seen the difference between working with, say, PHP without types and working with PHP with types. And I see day to day that it's saving our lives in production, saving us from ourselves, I'd say, because the compiler is telling you that you're doing something dumb, whereas without any types, you are in the dark. So I started this in October 2022. I was reading Crafting Interpreters, so you might know that book. It's a really good book in which you write a tiny language from scratch. And so I started a bit fun doing this with Zig, and I found that it was a good starting point to go further. And I got really further. I got, like I said, a little carried away, and Buzz became quite a complete language. So I didn't have any grand plan for it. I was just picking and choosing features from languages I was using. So I'm trying to follow a few principles for Buzz. The main one being I don't want it to become too complex, too big. So I think that it's a main challenge for anyone designing a language to draw the line where adding a feature, it may be fun, but it's maybe adding a little bit too much complexity to your language. And so I found that finding that fine line is quite hard. And because adding new features to the language is pretty fun. So, but still, I'm trying to maintain Buzz relatively small. I want also it to be small in size. So I think it's there. It's quite small. I'd compare it to Lua in terms of size. Other things I want to enforce is I want to avoid implicit or unexpected behaviors. And what I mean by that is that I don't want the language to do things that are not that you can't know about by reading the code alone. So there's no coercions, very little coercions in Buzz, and there's a little inferring of types or those kind of things. So let's have a quick tour of the language. So there's quite a lot to cover, so I'm going to go pretty fast on each feature. So if I'm going too fast or if it's not clear, you can ask a question and I'll answer it at the end. So here you have a sample. You have the famous hello world. So it's pretty straightforward. You have the main function, which is the entry point of the script, and you're printing hello world. Here are the types available in Buzz. So you have strings, you have mutable types. So I cover that later. You have numbers, you have data structures like lists and maps. You have patterns, which are PCRE regexes. And you have special types like any, which can hold any type of value, and type, which can hold a type. You can see here that I stole an ID from Zig, which is a test block. In Buzz, those are functions that are only generated and called if you call Buzz with the test option. So in it, you can see that when we call say hi to the function here, there's named arguments, default values. You can also see here how we do string interpolation. You can also see that we can pass function as values. Here we have an arrow function, and that we have generic types only for function right now, but it's planned to add them to objects too. So speaking about objects, so Buzz is not object-oriented, and we don't have inheritance between objects, but we have protocols. Protocols are a set of methods that your object has to implement if it conforms to it. So here you are the object person, and we implement the compare function, and we have static function. Here I'm using it as a sort of constructor, and we have special methods like toString, which is going to be called if you interpolate the instance in a string, and you have collect, which is called right before the object is collected by the garbage collector. Here you can see how we do instantiation of an object. And we also have anonymous objects, which are objects without any method or static variables. It's pretty useful if you have a few data that you want to bound together, and you don't want to define a type for it. So it's pretty useful for that. We have enums, so there's not much to say about them apart from the fact that you can associate a value for each case of the type that you want, and then you can get the value or create the enum instance from the value, and so on. So null safety is something I loved very much from languages like Dart and Swift. You also have a form of it in Zig. So here you can see we have a value that can be null. You can unwrap it with an if statement and an arrow. You can also use it in a chain. So this is something you can do in Zig, but you can in Swift or Dart. So here we could have any number of optional value in the chain. If anything becomes null, the chain is going to stop there, and the expression is going to evaluate to null. Otherwise, you're going to go to the end of the expression and get what you want. Here you can specify a default value if this expression evaluates to null. And here I'm saying to the compiler, I'm sure this value is not going to be null, so please unwrap it. So error handling. So like Zig, error have to be handled and have to be specified. So in this function, you can see that I'm raising two types of error. One is an enum, and the other is a string. And so if I'm not handling the error in the function itself, I have to specify in its signature that that's the types of error I'm raising. To handle the error, you can do both two things. One is to discard the error and give a default value. The other is to surround the call with a try-catch statement, which is doing what you would expect. So you can specify which type of error you want to catch in that block, or you can specify none, and so you will catch any error that are coming here. Another interesting feature are fibers, which are like Lua coroutines. So here is an example. What it is exactly is states of the VM, and the VM can point to any state and switch from one to the other with zero cost. So here, an example, the Fibonacci sequence. And you have two types here. You have the type that the function returns at the end, and you have the type that the function can yield. So here we are yielding an integer, but we are returning a string here. One thing we can do with buzz is call this function outside of a fiber. And whenever we encounter a yield expression, a yield statement, it's only going to evaluate the expression and discard the yield. Or we can call the function in a fiber. It's what we are doing here. And then we can resume the fiber to get the next yielded value. Or we can resolve the fiber, which is going to run the function until the end. Or we can use it in a for each statement as an iterator. It's gonna loop over the yielded values. The last feature I want to show you is a feature I've been working on recently, which are FFI. So right now in Buzz, if you want to call a C function, you can use the API. The API allows you to interact with a stack of Buzz and to start or stop a VM. And so you could do that. You could use the API to take arguments from the stack, convert them to the expected types of the C function, call the C function, take the return value, make it a Buzz value, and push it back on the stack. So you could do that to any function you have to implement, but it's quite time consuming. So what FFI is doing this work for you on the fly. So I'm using the just-in-time compiler of Buzz to compile wrapper functions around the native function to do the binding for you. Here an example. You have a zdef statement. You specify which library you want to load, and then you declare the API you're going to use using the code. And but you have to be compliant with CABI, which means you can't have any slices, you can't have error return values, that kind of thing. And then in Buzz, you can call those functions like any Buzz function, and you can instantiate structs like you would do an object. So what happens here, like I said before, is that the just-in-time compiler is going to generate a function which is going to do the binding for add and greater here. And it's going to do the same here. It's going to generate a getter and a setter for the field age and another one for the field name. So this feature was quite fun to work with. And so it's still a work in progress, but I'm going to show you what it can do. So I have an example here using SDL. So I'm declaring the SDL API I want to use. So you have some awkward things like this because I don't have unions yet. So since SDL event is a union, I'm just padding the struct to emulate the union. I'm just using the type, so it's quite okay. And here I'm declaring the function I'm going to use. I'm declaring some enums used by the API. And then I'm declaring some objects to wrap those calls and to make it a bit more idiomatic, a bit more like Buzz code. So here I have an object SDL doing initializing SDL, wait, polling, that kind of thing, a texture. You can see I'm using the collect function so that the texture is going to be destroyed just before the instance of the object is collected by the garbage collector. We have the renderer who is going to be able to create a texture, set the color, set the targets, and so on. And then here, I wrote a little game of life that you might know. So I have an object world, which is just doing the game logic. So for each cell, each time we're stepping into the world, we're going to decide for each cell if it's alive or not. And then here I have a function that draws to a SDL renderer. So I'm setting the color according to the fact of if the cell is alive, I'm going to paint it blue, otherwise I'm going to paint it white. And then I'm filling a rectangle where the cell lives. And here you have the main function when I'm initializing SDL stuff, so a window, a renderer, a texture, and the world. And then I'm starting the game loop, which is going to poll events, expecting if a quit event arrives, I'm stopping the game loop. And here I'm drawing the world and I'm stepping it to make the logic advance. And I'm rendering it to the screen. And it's this what it looks like. So you can see here, I specified an option to tell Buzz where the SDL library is on my system. Otherwise, it's going to look to common places. Since Homebrew is in its own little world, I just had to add a path to the SDL library. So let's go back to the talk. So I'm going to talk now a bit about the architecture of Buzz. So Buzz is a stack-based VM. I applied a little bit with a registered-based VM. Maybe I didn't do it quite well, but I didn't find that the performances were that better. So I'm still using stack-based VM. It's using tail called dispatch, which means it's not a big switch over the bitcode to execute. It's just each bitcode is a function that is going to call the next bitcode to execute. There's a generational garbage collector, and that's the API I talked before about, which is compliant to the C API. So you can use it from C or you can use it from Z. And there's a standard library, which is written using that API. So we have a just-in-time compiler. It's using Mir. You can look it up. It's a small project. It's very focused, and it's small in size, it's small in complexity, but it's really fast. And I'm quite happy with the experience I had using this. So it's a function-based just-in-time compiler for the time being, which means I'm only compiling function when I see that they are called too many times. So I compute a threshold, and when it's over that threshold, I'm compiling the function. In the future, I'm going to be able to compile bits of code, so maybe a while loop is going to be transformed from a while loop to a function, and I'm compiling it there. So it's planned. Buzz is supporting right now Linux and macOS. Windows is planned. There's nothing preventing me from making the project work with Windows. I just have to have a Windows machine around. So it's going to be, I hope, in the next release. So here, what it looks like. So for people used to languages, you might recognize a lot of it. So we are feeding the source code to a scanner, which is going to tokenize it, feed it to a parser, which is going to generate typed AST. Then we have the code generation, which is going to do type checking and bitcode in the same time. And then it's going to give it to the VM, which is going to run it. The VM can switch, like I said, between any number of fibers. And anytime it needs memory, it's going to ask the garbage collector to give it some. And the garbage collector can decide to collect garbage. We have the just-in-time compiler, which is going to compile any functions that needs to be. And we have the standard library using the API, which is going to interact with the VM. So the standard library of Buzz is really just taking advantage of the standard library of Zig, which is really rich. You can do whatever you want actually with Zig stdlib. So it's really just a wrapper around those things, and that's why you can already do a bunch of things with Buzz, because you have standard libraries that can do quite much. So the basic things like files, memory sockets, file system stuff, etc. And you have the buffer library, which is basically an object allowing you to manage a chunk of memory. And it's really useful in combination with FFI, because whenever a C function is going to ask you a pointer to some kind of data, you're going to use a buffer. And then there's still stuff I need to work at. So HTTP, I'd like to have an HTTP server and client, and some cryptographic things, and so on. So what I'm going to do in the future with Buzz, I have about 100 issues open right now. About 70% of them are features or things I want to improve, and the rest are bugs I want to fix. So for the next release, I'm going to focus on FFI, which is getting there. I just have to add things like unions and so on. Another point I want to focus on are performances. So right now, Buzz is not the fastest of languages. My goal is to reach at least the speed of Lua. So there's quite a bit of things I could do around garbage collecting and memory in general. So maybe have a smaller data structure so that things take less space in memory. And on garbage collecting, there's a ton of stuff I could do because the garbage collector right now is really a simple one, and there's a lot of literature around that topic, and I could do a lot of stuff. So I see what I'm going to do, but the choices are multiple. I can also do bitcode optimization because right now I'm just emitting bitcode and running it right away. But what I could do is do another pass to inspect the bitcode and simplify it, optimize it where it needs to be. Another big thing is finding bugs, which are quite easy to find right now. But the best way to do so is to write buzz code. So I'm starting some small projects to be able to write as much buzz code as I can to find bugs. I also like to have Windows support and WebAssembly. Windows is pretty straightforward, but WebAssembly is going to take a little bit more of effort. And lastly, what I want to do is have a language server protocol. So I just already started it. It's not that hard to do, but there's a lot of ground to cover. It's gonna be time consuming, but I already started it, and it's quite fun to do. Another thing I'd like to have is a debugger adapter protocol, which will be really helpful for people. So if you want to follow where Buzz goes, you have those links, you have the home page, you have the GitHub repository, and we have a Discord. So please feel free to join the Discord, ask questions, play with Buzz, and I really would appreciate any feedback on it. So there we are. I'm really thankful for everyone to have listened to me. And Loris, I'm gonna let you take over.
Okay, thank you. Let's switch to the Q&A view then. Thank you very much, Benoit. There was a very nice rundown of what you're doing with Buzz. We have, so I guess I maybe should apologize, but I think this comes with the territory. I think that you're going to have a bunch of questions about syntax. So it's going to be a lot of bike shedding. I hope you don't mind this, but I'll start with my own bike shedding question. So I've seen...
I'm used to it.
You're used to it. Yeah, I mean, it comes with the territory, I guess. So, also, wait. Are we good? Can you hear me well?
Yeah, I was only hearing you in the.
Oh yeah, that wasn't me.
So
I
that's
fixed
okay.
It. Sorry. Sorry, guys. That's me not being a good host. So here's my question. I've seen, Dave, you have taken. It seems to me you have taken a few style ideas from Swift, and I think I can also, I share your appreciation for some of the syntax of Swift, especially before Swift UI became a thing. Now I used to know Swift, now I don't know Swift anymore. But there's one thing that you did different. You moved types left to the variable name. Like you have type and then variable name, while more modern languages, like lately, the trend is to put the type after the variable name. Do you have like I don't know? Do you have like a big story of how that decision came into being?
It wasn't really a decision, so tells you how natural it was for me. I didn't really think about it, really.
Oh.
But if I have to say something about it, I'd say that in a type language, the first thing I want to know about something is what type it is.
Mm-hmm.
So I feel it's natural for me to read the type first and then the name.
Understood.
But really, it wasn't a big decision. I didn't ponder about it.
Mm-hmm. Are you open? So if now some people from chat come and start saying, would you be open to changing that? Would you?
I don't know. I'm open to a lot of things. So people are
Okay.
complaining about many things about the syntax. The first thing people tell me about is the
Mhm.
character I'm using for comments. And there's two things. So one is I'm saying to myself, it's really not that important what the syntax is sometimes, and sometimes it's quite a bit of a decision to make. I'm
Mhm.
open to anything. The
Okay.
language is really not set in stone. So if you come several months ago, I only had one type for numbers, and I split it in integers and floats. So I'm really open to things,
Okay.
but I don't really see the point of moving this now.
Understood. Okay, so another question about syntax. Less bike shedding in mind, though. I think this one is more interesting. This one comes from GW1. Is there a reason other than just being convenient that you use Zig syntax for FFI?
It's convenience because in the standard library of Zig, you have Zig, std Zig AST, which is
Ah,
parsing Zig stuff for free. So I have an AST to use,
nice.
and I just had to use that and to use. So I just copied the Zig types definitions, which are com type, and so that I can use it in runtime. And that was it.
I
So
see.
the next step I want to do is have a C dev statement, which is going to do the same with C. But it's another challenge to do this. Maybe I'm going to use arrow CC, see what I can do with it. But right now, it was free, so you just took it.
Right. That seems a very sensible choice. Another question from this one is from Andrew. Are you or anyone else using Buzz in a third party project? Can you share some more about this or at least your future plans for this?
So I'm really the only person to use Buzz right now.
Mhm.
Uh, so like I said, I'm trying to use it uh, for doing small projects with it. So one thing I maybe can show you,
Yeah,
if I can bring my, yeah, here. Um, is this. So it's quite early to show this, but I'm gonna do it anyway. So you can see some debug stuff here, but mainly it's a small command line software to write notes about stuff. And you can add notes, list notes, and it's saved in a SQLite database. So I wrote FFI for SQLite here. See, and like I did for SDL, I wrote some helper objects, wrap things around to statements. So here's the nice thing. The nice thing here is that when I'm running SQLite statements, it's in a fiber, so I can iterate over the result.
nice.
So, I'm yielding here the row, and at the end, I'm returning the whole the result. So that's it. So, like I said, so I'm not the only user with it really right now, and I don't push people to use it just yet because there's a lot of bugs to find. And just doing this small project, I find a bunch of them. So it's really not, definitely do not use it to do actual work. And maybe in a few months, we can use it to actually do stuff without too much bugs.
Um, so I have a couple more questions. One is, um, so now since you have like fibers, have you had a chance to try out async await in Zig?
No, I didn't. Uh, I don't even know how it works. I just heard that it was there and then not there. So I
Yeah.
was just waiting for it to be uh, a little stable.
Okay, cool.
So
Yeah. Mhm.
one thing I can say, just not really related to async await, but related to Zig, is that Buzz is following Zig master.
Mhm.
So anytime I'm pushing something to Buzz, to the repository, it's going to run the test with a nightly build of Zig. And so this is quite a lot of work actually, because a lot of things are breaking and you end up,
Yep.
you have just finished working on a feature, you're pushing it, and you find out that you don't have the actual last Zig version, and it's going to break a lot of stuff. So
Yep. So, well, yeah, I was asking out of curiosity because it makes sense. Like we are in a transitional moment when it comes to async await, and I can see people who might have joined after we switched to the new compiler and who haven't had a chance to try it out yet. So cool. I'll look forward to hear what you think about it once it comes back to the compiler and you have a chance to try it out. So here's my next question. Do you have did you ever add any like very funky experimental feature to Buzz just to try it out and then discover that you didn't like it? Or do you have anything in the back of your mind that you would like to eventually try out? You know, something non-conventional.
I'm trying to think. So not really something unconventional, but there's conventional things I'm thinking about.
Mm-hmm.
So one thing is I'm thinking about right now is mutability or immutability by default. So right now, Buzz is mutable by default. So any value you define, if you're not saying const, it's going to be mutable. And I'm thinking about doing the opposite. And I'm just pondering what the cost is going to be for me to write it, change it, and what it's going to feel like when you're writing Buzz code.
Right.
That's one thing. One other thing I could say, the small stuff, like I wanted to have the guard expression of Swift. I don't know
Right.
if you know about it.
Oh
So
yeah.
when you have an optional value, and you can say guard, if that value is null, please get out of the scope. Otherwise, promote the value to a not null value, so you can use it in the rest of the scope. So I did it, I implemented it, and then I was like, maybe it's a bit too much for Buzz, and I have to, like I said before, the hardest thing is to draw the line at some point and stop adding features. So
Yeah.
I made it, and I just didn't merge it because I was like, I'm just not gonna do a Swift point 7. And Swift is a good example of a language that's never stopped adding features. And like you said, you used to know Swift. Also, I used to know Swift. I worked on it several years ago. And if I wanted to do something in Swift right now, I would be lost. And I just don't want the same thing for Buzz.
Makes sense. I also remember that, yeah, so the guard stuff, like the idea, it's basically like implicit unwrapping, right? You check for nullability on a value, and then afterwards you implicitly unwrap it. Now it's not optional anymore. Now it's the actual unwrapped value within that scope. I also remember, yeah?
Yeah, null safety is really, really useful, but it can get in your way.
Yeah.
If you don't have many tools to use it. And so I was looking to any tools I could add to the to Buzz so that it's easy to use. So right now you have the like I showed before, you have the if statements, but that means that you are adding a new scope and you are incrementing stuff to the right, and it can pile off. So that's what I wanted to avoid with the guard statement.
Makes sense. Yeah, but I also remember when these features would also cause Xcode to crash a lot. Like, I don't know if this was this feature specifically, but like the general approach of Swift of being like feature rich and having a lot of magic happening behind the scenes a lot of like inference and stuff, and it would crash Xcode like very often. At least that was my experience at the time. So we have
Still the case.
Yeah, still a case. Okay.
Yeah. But it's not crashing, but it's really slow.
Yeah, right.
It's really too bad because Swift is a great language, but if you're outside of the Xcode of Xcode, you're quite lost. Because there's a language protocol using I don't know the name of it, but using what it is. Using something of Swift to do it, but it's not the same. And if you're in Xcode is just a pain in the ass. It's really slow.
Yeah.
And it's too bad for a great language.
Okay, so we got 3 more interesting questions. So I think this one we can like end with these 3 questions. So the first one is, did you profile memory usage of Buzz? Like, have you ever, for example, tried to run it on like a microcontroller? And do you think that would work out?
So I did some stuff to watch the memory, but it was really to debug the garbage collector. So actually, the demo you saw using SDL was the first time I was running really a loop that's gonna use memory really fast for a long time. So it was quite easy to see that there was some issue in the garbage collector. As for the memory footprint of Buzz, I don't really know. I didn't really look. And so, like I said, it's something I want to work on for performances and for the size, because I said that I want Buzz to be small, so I'm going to reach that goal. And but I didn't measure it really precisely right now. I just wanted to have a garbage collector that works, actually collect garbage, and
so it's in scope. You don't know yet, but you expect the language to eventually be able to be used for that. Makes sense. Is there any specific use case that you have in mind for the language, like some kind of sometimes people, I don't know if that's what the question meant to ask, but like I'll add a little bit of my thoughts to it. Sometimes people think about a killer app for the language, but you're probably not thinking exactly in those terms. But like a use case that it like your language fits particularly well. Do you have any in mind?
So the history behind Buzz is me working a lot with Lua. So I did Fengari, like I talked before, and I made a lot of games using it. And when you make games, your code base is going to grow really fast. And the issue with Lua is going to not really scale well because you don't have any types. So you end up debugging for hours and hours because you have a big code base and it's really hard to find what the issue is. So what I want Buzz to be is whenever you would want to use a language like Lua, but you want it to scale, you can use Buzz because the compiler is going to save you some time.
Right. Perfect sense. Okay, last question. Will Buzz have sandboxing? So like, for example, restrict memory usage and or CPU usage of scripts?
Sandboxing in the feature realm, so preventing a script from doing stuff it's not supposed to do.
Yeah,
it's pretty easy. That I can do right now. I just have to compile a version of Buzz without the standard library and stuff like that. Restraining in terms of memory is also quite easy. You just have to tell the garbage collector you only have that amount of memory you can use. I don't know how I could do it with a CPU right now. Just didn't think about it.
I guess you would have to implement something like some kind of like currency, like a number, like a counter that basically after which you run that many VM instructions, then the VM automatically yields to the host, kind of, I guess.
Right, that would be easy to do, yes. Yeah, easy. Actually, if you have just-in-time compiled functions, it's going to be a little bit harder to monitor.
Right.
But if you're only talking about bytecode, so you can build Buzz without the just-in-time compiler. So in that settings, you could say I'm building Buzz with a standard library without just-in-time compiler, and you can restrain the memory usage and the amount of bitcode you can run.
Mm-hmm. Andrew had a nice comment that I think it's worth repeating for the people who are going to watch this recorded on YouTube. Since you were pointing out that like the JIT might mess up your like instruction counting, Andrew was saying that it might be worth getting the OS involved into this procedure. So like have the OS, which can provide you with performance counters, basically help you do that counting. So I'm sure there's a lot of complexity there that I'm not aware of that doesn't make this trivial, but it does make sense. Like whenever something runs on the physical machine, then that's where you can start collecting some. It's worth having external for performance numbers coming. Anyway,
I'm gonna look at this.
Nice. So thank you very much. This was a great talk. I think this was not just a great talk, but also a great example of what I think Showtime is kind of about, like Zig Showtime. It's not just about public figures like Mitchell, who we had last time. It's great to have him, but it's also about Zig projects made by the Zig community, maybe not necessarily only for the Zig community, but like also us who usually don't have a platform. So that was great. Thank you very much. Is there anything you want to say before we end the show?
I just want to thank you, Loris, for giving me the opportunity to talk, and for you people who listened to my really terrible English for that many times. and so really thank you, and please join the Discord of the project. I want to hear people's opinion, and it's always helpful.
Nice. Well, thank you very much. And with this, we're going to get to the end of the show. So please do check out Buzz. And well, I guess I'll see you next Showtime. Bye.
This is how we